Section 1.3, Algebraic Expressions. You've probably done something like this in the past where you've had an addition question where you've just got a blank, something plus 6. And you'd be able to, from there, tell me what something plus 6 was. For algebra, people hear the word algebra and they start to get upset or scared or something like that when they hear algebra, because algebra is supposed to be really difficult. But it is a basic thing where you're just filling in the blank. So for instance, something plus 6, I could also look at that as a letter, n plus 6. All I've done is replace the unknown, the number that we don't know, with a letter. Sometimes we replace the blank space with a letter when we don't know what that number is. Expression, when I say an expression, it is not an equation. There's something missing from here that doesn't allow it to be called an equation, and that's an equal sign. There is no equal sign, so it's not an equation. It's an expression. The expression is n, a number we don't know, plus 6. It's an expression for the relationship that with n. N would be a letter, but n plus 6 is adding 6 to a number that we don't know, or a specific number. So wording is important when you're creating expressions or reading expressions. If you look over here, this is an n plus a 7, so you can read that as a number plus 7. Over here, you can look at it as n times 3, but the problem is when you add an x there for the multiplication sign, people automatically think that that means nx3. So when we're writing algebraic expressions or eventually algebraic equations, you put the number and the letter right next to each other. So 3n is the same thing as n times 3 or 3 times n. It's just we're eliminating the multiplication sign. Anytime you see a number right next to a letter without a sign in between them, or an operation without addition, subtraction, multiply, or divide, this means multiply. So that would be 3 times a number. 3 times a number. We don't know what the number is, so we're just using n and calling it a number. Now this one's a little more difficult. When you're doing subtraction, it's a little bit of a longer expression, and you can say it two ways. 10 less than a number. So 10 less than a number, or a number minus 10. You still don't know what the number is, so you're just saying a number minus 10, or 10 less than that number. Subtraction. And then the last one is division. This sign here in the middle indicates division. When you see a letter above a number, or for that matter, a number above a letter, in a fraction state, that means division. So in this case, it would be a number on top, divided by 6. A number divided by 6. If we start at the top, a number plus 7, 3 times a number minus 10, or 10 less than a number. And for division again, a number divided by 6. When we look at an actual algebraic expression, 5k plus 2. That is an algebraic expression. 5 times a number plus 2, or 2 more than 5 times a number. Again, there's no multiplication sign. When you see a number next to a letter, that automatically means multiply. Now, each of these letters and numbers has a specific name. And in this case, the k is the variable. We don't know what that k is. It represents a number that we don't know. So it's called a variable because it will vary depending on what we put there. The 5 is called the numerical coefficient. And that's a really big way and a really fancy way of saying that the 5, because it's a number, so it's numerical, and a coefficient, it works in conjunction with the k. It's directly related to the variable. It's directly related. So it's called the numerical coefficient. And the 2 is a constant term. The 2 isn't directly affected by the k like the 5 is. So you just need to remember those names. If I ever mention the variable is the letter. The numerical coefficient is any number that is attached to the variable, and the constant term is always the one being added or subtracted. Sometimes you won't have a numerical coefficient, and sometimes you won't have a constant term. It might be 5k or k plus 2, but you'll have a variable no matter what. So now one of the big things is how to evaluate an expression. It's not answer an equation, it's evaluate an expression. We don't have an equals sign in our expression, so it's not an equation. You're evaluating it. And what you need to do is you need to replace that letter. When you're doing an expression, you'll be given what that letter represents. So in this case, we're going to say n equals 4. Okay, so n plus 8, again, going back to the idea that it's something plus 8, and that something is we're being told is 4. So we're going to replace the n. We go down to the next line, we replace the n with a 4, and now our expression is 4 plus 8. And then we add 4 plus 8, and we get 12. So we started n plus 8. We say that, okay, well, what if n equals 4? If n equals 4, it becomes 4 plus 8, and 4 plus 8 equals 12. Let's try that again. We're going to do a little bit more involved one this time. 4k plus 2. Same thing as before. We're not answering an equation. We're evaluating an expression, which means we're going to be given what that letter is. And that should say, actually, that should say k. K equals 10, not n. I just copied it from the last slide. But your variable equals 10. So we come over here, 4k plus 2, and we replace our variable with the 10. 4 times 10 plus 2. We're going to use something called bed mass. We're going to talk about this a little bit more in class, but it's the order that you do things. Brackets, exponents. We don't have... we're looking at brackets, exponents, division, multiplication, addition, subtraction. Technically, this is a multiplication, 4 times 10. When you have a number next to another number in the brackets, that's automatically multiplication. 4 times 10 plus 2. We do our multiplication first. Okay, 4 times 10 plus 2. We do our multiplication first. 4 times 10 is 40. Plus 2, we do our addition, 42. So our original expression was 4k plus 2. We said that the variable equals 10, so we put the 10 in. 4 times 10 is 40, plus 2 is 42. So to evaluate that expression, 4k plus 2, with the variable being 10, we get 42. So here's your practice question. I want you to write the following sentence as an expression, and then I want you to evaluate the expression as if n equaled 5. So 2 more than 3 times a number. 2 more than 3 times a number. I want you to write this sentence like an expression here. Like we have this one here. 2 more than 5 times a number. 2 more than 3 times a number. And then once you've written that expression, I want you to evaluate that expression as if n equaled 5.